Here you can see the landmass divided into different parts. Also, you can see the oceans have also been divided into different parts: Indian Ocean, Atlantic Ocean. Why are land masses not at one place? And same for the oceans. We'll see in this video. So continental drift theory, seafloor spreading theory, and the plate tectonics theories are the three theories which attempted to explain the distribution of ocean and the continents. Let's start with the continental drift theory. Postulated by Alfred Wegener in 1912, he said there existed a supercontinent Pangaea and superocean called Panthalassa. Pangaea was to the south of the equator line in Paleozoic Carboniferous period. So Alfred Wegener was referring to this period, right? Beyond 250 million years ago, Paleozoic and Carboniferous. He later says that in Mesozoic, that is 200 million years ago, splitting of this huge land mass starts and divides into two parts. One goes to the north and the other goes to south. The northern part is known as Laurasia and the southern part is known as Gondwana. He further says that these land masses are Cealic and the ocean floor is Sima, right? And the Cealic block moves over the Sima, right? Then the reason for this drifting he gives, the driving force is the tidal forces. Tidal forces are the gravitational attraction of the moon and the sun, and the pole fleeing forces, right? Let's see what are some of the evidences of this particular continental drift theory. First, the jigsaw fit evidence. If you see the South America and the western part of Africa, India, Madagascar, Antarctica, and Australia, Tasmania, Guinea, they all seem to be fitting, right? So that was the first evidence, number one. The second evidence is the geologic evidence. And in geologic evidence, there are several evidences. The first evidence is the fold belts, the matching of the fold belts of North America and the Europe, right? First of all, what is fold belt? Fold belts are the belts which are the mountain chains which are formed normally due to the continent-continent collision, right? Now here you see the North America, here is the Greenland, Great Britain, this is the Norway, and this is part of Africa, right? So this is, if you see clearly, the Scotland area, right? Ireland, the Green Belt, right? Greenland, the Baltic Shields, the Appalachians, these all are of same age and they all have similar linear trend. The next are the tillite deposits. First is water tills. The tills are the rounded clast, and when these rounded clast, they are deposited by the glaciers, right? Now when these depositions are metamorphosed, till forms into tillites. So these are the sedimentary rocks that consist of unweathered blocks, large and angular, and they have the glacial tills. What are glacial tills? Unsorted, unstratified rock materials deposited by the glacial ice. Now some of the characteristic features or the indicative features of the tillites are these will have the scratches because the striations the scratches caused by the glacier. Secondly, the gravel itself is unstratified. You won't find any sedimentary features. And thirdly, very poor sorting. At one hand you will find blocks, at the other hand you will find very small size sand, right? So why is it an evidence? It's an evidence because these tillites have been found all across, right? And the India's Talcher boulder belt, it's same as the late Paleozoic beds, right? In Paleozoic, right? So this is the Paleozoic period, that is beyond from 250 to 540 million years ago, right? So approximately 300 million years ago, these the glaciers were going towards the northern part, towards the Central Africa, towards the Central South America, towards the Central India, right, towards the northern part of Australia, and complete of Antarctica, right? So the striations are towards the north in India, towards the north in Australia, towards the north in this region, right? And the South Pole was somewhere found in South Africa, right? So this is the second evidence. Thirdly, we have coal deposits. Now in Carboniferous was also a time when the geological forces made continuous wind continents together, right? If you see, Pangaea started forming 300 million years ago. It stopped at 270 million. I mean, complete Pangaea was formed, and by 200 million years ago, it again started distorting. It again started separating. Now, when it collided, when the two parts, I'm talking of somewhere between 300 to 270 million years ago, when two land pieces were colliding, forming Pangaea. Right, high mountains were formed, leading to very large rivers forming. Large basins were formed because of large rivers, and in equatorial regions, the swampy conditions led to massive organic matter getting preserved, and hence we see that if you see the coal sequence, the North American and the Europe, they match. The coal fields of North America and Europe match, right? Because of similar climate. Secondly, how can anthracite be found in Russia and the Appalachians, right? Because they are in either temperate region or polar region where there is not so much of vegetation, but still because they were at some time near equator, and hence we can find anthracite because such conditions were there to preservation, and hence anthracite is found in pole regions of Russia. Similar goes for the Antarctic and Arctic, where the tropical fossil evidences in coal is found, right? The next are the rocks. If you see the Precambrian anorthosite, it is common in the Africa, Madagascar, India, right? And this is only possible because these all places were joined together. Similarly, the Mesozoic dolerite is common in South Africa, parts of Antarctica, and Tasmania. Okay. Similarly, in Ghana, which was earlier known as Gold Coast, gold is found, but there is no gold producing rock found because all the gold producing rock have gone into Brazil. Okay. Similarly, the North American Appalachian Mountains and the European Caledonian and the Scottish Highland, they all have the similar rocks, right, of same age. And finally, we have paleontological evidence. Two very important paleontological evidences are first Glossopteris. Now, Glossopteris has come from the Latin word glossa, means tongue, and pteris means fern or feather, right? It was a seed fern, and this plant has its fossils in South America, Africa, Madagascar, India, right? Parts of Sri Lanka, Antarctica, and Australia. And this is only possible because the plants cannot, cross the oceans. That means the land must have been joined at one time. Secondly, a dog size or a pig-sized reptile known as Listosaurus. It was found in Africa, Madagascar, India, and Antarctica, and this is only possible if the land was joined, because this land creature cannot swim and can go to another areas, right? And the last evidence given by the Alfred Wegener was the paleomagnetic evidence. Let's see what it is all about. Now, Wegener collected the paleoclimatic evidences from the sedimentary rocks and found many ancient climate belts
which were in different position from the present belts, right? The shift in the climatic belts is known as the polar wandering, right? What is polar wandering? That is the apparent movement of Earth's geographic north and south pole. Now, this apparent movement can be because of two things. First, either the continents were immobile and the poles were moving, or the poles were stationary and the continents were mobile, right? So Alfred Wegener, he was of the view that definitely he plotted the APW curve, that is apparent pole wandering curves. You can see here Cambrian, right, and Devonian, it was somewhere here, the pole was somewhere here, the apparent pole was here, and finally Permian, it's here, and to further time it was here. Now Wegener assumed that straightforward the continents were mobile and the pole were stationary, right?
But again, there were some shortcomings in the theory given by the Alfred Wegener. These shortcomings were, first, what is the origin of Pangaea? Right. He didn't explain what was before Carboniferous period. Was Pangaea joined together? Was Pangaea had earlier again splitted and had joined? Right. And why was it splitting? What is the drive? What is the force which is splitting? He says it's the tidal force, but in reality tidal forces are very weak, right? And Sial doesn't move over Sima, but in complete Sial plus Sima, that is the continental block and the ocean block, incomplete, move over the asthenosphere, right?
And hence also one of the criticism by many contemporary people that the pole wandering at that time could also be because of the pole wandering curves, could also have been because of the actual poles wandering and the continents being stationary, right?